Hello class, this is me, Mr. Wee again. We're down to I think about 2 more parts and we're pretty much done for month 7's content. So we're just going to look at more things with similar triangles. In this case, we're going to look at specific parts of similar triangles. So we're going to look at 3 things I think that are going to be pretty easy to understand. Let me just walk you through them, okay? So in each of these 3 cases, or each of these 3 theorems, we're going to look at cases of all triangles being similar and then the results of triangles being similar. Okay, so in this case here, it's going to be pretty nice. You can actually just pause and read these. You can actually put these on your cheat sheets if you like, special segments of similar triangles. If you don't recall what this is, these are altitudes. So let's look at the first one, 9-8. So let's zoom in on 9-8, I guess. So on 9-8, it says if 2 triangles are similar, so we've established that A, B, and C, and F, G, and H are similar, meaning that their sides are going to be proportional to, or the ratios of their sides, like A, B to F, G, is going to be, that ratio is going to be proportional to if we compared CB to GH or HG. Okay, so and what this says is that if you drew a corner one from a vertice to the other side, to the opposite side of that vertice, making an altitude. I don't know if you remember the altitudes. What this basically says is that the ratio of the altitudes, AD to FG, is going to be comparable to if you compared another side on the similar triangle, AB to FG. So let's say AB to FG, it gives you a ratio of 3, then the same thing can be said if you take the altitudes AD and FJ. Sorry, FJ is what I meant to say earlier. AD and FJ should also be the same ratio. Okay? So that's what it's saying here, basically in this ratio here. This is no different. Instead of doing altitudes, now we're doing angle bisectors. So basically what this is saying is if 2 triangles are confirmed to be similar, then basically the ratios between an angle if you drew an angle bisector similarly, like LP is very similarly drawn to RT in the same kind of, or in a very similar vertice, okay, in the similar positions of the similar triangles, then the ratio of like the angle bisectors, let's say LP divided by RT, like in this case here, the ratio here, the ratio they make should be equal to the ratio of, like, let's say corresponding similar sides, like another pair of corresponding similar sides, like LM is comparable to RS, and that's what we see here. Okay, so that's all that's saying. The ratio that the angle bisectors make should be equal to the ratios of any other corresponding sides of the similar triangles as well. Same thing down here with medians. If you forget what medians are just if you drew from a corner of a vertice and then you bisect, or you intersect, or yeah, you basically bisect the other segment across from that vertice, meaning that from C I draw to a point D in such a way that the opposite side is cut in half. Okay, so basically what this is saying is if you have 2 triangles that are similar, then their medians will create a ratio that is the same as the ratio if you took another pair of corresponding sides, let's say A to B. So let's say CD divided by YZ, which is what we have here, will create the same ratio as if I just took 2 other corresponding sides that should be similar. AB and WX make a ratio that is going to be equal to the ratio of the medians. So what is this going to look like in the math? It's going to be pretty simple. Let me give you a sample problem really quick. So this would just be a very basic problem, and then the next video we're going to go through something a little bit more complicated, but with the same idea, nothing too different. So right here, let's draw 2 triangles. So let's sort of make this not a right triangle, but let's do that. ACB, and let's do that. This is going to be an angle bisector, so let's make an angle in the corner here. And let's bisect that angle. Okay, so this is not what is it? I always forget. This is not a what is this? I forget what this is called. This is not a median, but this is just an angle bisector. A median would have cut CB in half, but it didn't. It only cut the angle in half here and here. Okay, so this is going to create a point here, A to P, that is x long, and then AB that is 15 long. Now, what's going to look sort of confusing is I'm going to kind of draw this a little bit differently for the triangle that's similar to this. So be forewarned, it's going to look a little bit different. They look sort of the same, but be very careful with the way I draw these things. So notice the way I write my notation. Triangle ABC is similar to triangle FDG. Be very, very careful. ABC is going to be similar, whoa, look at this, from F to D to G. So actually FD is actually going to be similar to, actually FD is similar to AB, and what's different now is that the angle in this corner will be bisected by this guy here, FQ, okay, and this will be 8, right? So let's see. So AB and FD, so we'll say AB and FD are corresponding sides that are similar to each other. So they'll make a ratio that is 15 divided by 12, okay? Not a big deal. Now, we want to compare the angle bisectors. So basically what this theorem says, or what like our last theorems are saying, that these triangles are given to us as being similar to each other. Okay, so that means that not only are their sides similar to each other in a way that it makes a ratio, but the ratio should also be the same as the ratio when we compare the actual angle bisectors. So last time we went from the bigger triangle side to the smaller triangle side. We're not going to do anything different. We're just going to say that this ratio should be equal to, let's say, the ratio of the bigger angle bisector to the smaller angle bisector, x over 8, or specifically AB, or AD, I'm sorry, AD, A to D in comparison to F to Q. Okay, so all we have to do now is just solve for x. So the whole point of this was to solve for x. So we'll cross multiply. We're just looking at this mathematical relationship. We cross multiply 18 times 5, if I remember, is 120. And then 12 times x is 12x. We just divide both sides by 12. And then we should get that 10 is equal to x. And that's it. That was a pretty simple problem. And I have one more problem for us to go through that's going to be probably a little bit more difficult, but it's going to be pretty much the same. But hopefully you get the drift now. You're going to do this not just with medians, but or not just with angle bisectors, with medians and so far. So if we look at some examples that you might see in the future here. Okay, so if these two triangles were similar to each other, we just look at the middle parts here and here, like the odd type of part, or the special part in the triangle. In this case, if it goes from a vertice to the other side and makes a 90-degree angle, that's an altitude. So basically we know that the altitudes of these two similar triangles are going to be comparable. So I'm going to set up the ratio of 16 divided by x, and that's going to be comparable to the ratio that two corresponding sides. I know that this is a corresponding side because it's adjacent. It's very close to an angle that is actually congruent to this angle over here. So that means that this side that's 20 length, km, is going to be congruent, or not congruent, but similar to yx. So I know that 20 over 15, this ratio is going to be equal to 16 over x, let's say, to solve for this problem. And then in this problem, what you're going to end up going as, I'm going to speed up a little bit. I know that 3 and x will end up being the same, or not the same, but very similar. So the ratio of x divided by 3 is going to be similar as when we compare the actual, this is a median. These two lines in the middle of these triangles are medians. So I know that the ratio that this makes, pt over QW, is going to be 13.5 divided by 9. That should be, you're going to set that equal to x divided by 3 to solve for x there. Okay. All right, guys. So hopefully that was a little bit speedy, but I think this section is a little bit more intuitive or quick to understand. I'm going to go over one last problem in the last part, and you guys, let me focus this. You guys take care. Okay. I'll see you then.